Okay, let's get into circles. So in order to start talking about circles, we're going to have to define the equation of a circle. So this seems like a slightly terrifying equation, x minus h squared plus y minus k squared is equal to r squared. But once we get used to using it, you guys will probably figure out that it's actually not too terrible. And so what all the pieces mean is that h and the k is my center, and my radius is that r. And notice how it's r squared. So if I have an equation written out, I'm going to have to take the square root to find r. And then the other thing to notice is that there is a negative in front of my h and my k in the equation. So let's say I have an x minus 2 squared. That means that my h is actually going to be a positive 2. So you almost have to flip the signs. So to see in practice, I want to write the equation of the circle with a radius of 3 and the center is at 1, negative 2. Well, I'm just going to fill out that equation that we have boxed, put in 1 for my h, plug in negative 2 for my k, and then 3 for my r, and then I have to simplify a little bit. So 3 squared is 9, and then if I'm subtracting a negative 2, it becomes a positive 2. But notice kind of that shortcut that I was talking about. Yeah, I probably should always formally substitute in my point, but really what's going to happen is I just flip the sign and put it next to like the indicated variable. So I had a positive 1 as my center, so I get x minus 1 squared. I have a negative 2 as my center for y, and so I flip the side and make it a positive 2 in my equation. And the same logic kind of works in reverse. So now I have my equation x plus 3 squared plus y minus 2 squared equals 25. So I can flip the signs of whatever is inside those square roots, and my center is going to be, well, negative 3, 2. And then I just have to be careful, and this is kind of an issue that I see a lot. If I have 25, in order to find my radius, I just have to take the square root of 25. Now, graphing circles. Graphing circles, again, if you're just straight up using the equation, it seems kind of terrifying, but now that we know kind of the properties from the equations, it's more accurate that we're actually going to sketch the circle, but for all intents and purposes, we're going to graph the circle. So I'm going to identify those two pieces of information. My center is going to be 1, 2. My radius is going to be the square root of 9, which is 3. And then to graph it, what I'm going to do is I'm going to plot the center, and then I'm going to plot a point 3 to the left of it, 3 up, 3 down, and 3 to the right. So I have those points. And now I'm drawing a circle that has to go through those green dots. So my circle's not going to go through that red dot, which is the center. It's going to go through that outside. I just kind of draw a ring around it. And so that gets me my circle. And so if this question shows up on a test, I believe historically there's been one of these that have either showed up on the first test or the final. Essentially, you follow that scheme, and it's going to be done on a grid. So you'll actually be able to graph a fairly accurate circle. Where if you're doing this for your in-class assignment and you are sketching it, it's not going to be entirely accurate. I'm more concerned about, can you plot the center, can you plot the points, and then can you roughly draw a circle that goes through those points. Now, the hard question from this section comes from when we have something written in general form and we want to make it into the form that we saw in the very first slide, that equation of a circle. Because once we have that, we can identify pieces of information, we can go ahead and graph the circle. It's actually not, I feel it's not super difficult, but getting it into that form is a little bit tricky, and it's going to rely on a skill that we saw, I believe it's the second week. I mentioned it first week, but it was the second week, and that skill is completing the square. So I have my equation here, and my first step is I'm going to subtract 9 from both sides. Now what I do is I'm going to do completing the square, except for I'm going to have to do it twice. So I'm going to put in a blank next to my x's, I'm going to put in a blank next to my y's, and then I'm going to put 2 blanks on the right side. By the way, if this is the first time you've approached this problem, you might be saying, well, why are you actually going through completing the square? What tipped you off? Well, I know that the general form of a circle has to have that x minus 2 squared or the y plus 3 squared, or wherever it's going to be. And so that's kind of where my thought process goes to say, oh, that looks very familiar to what we did in week 2 of taking a general form and shrinking it into a single parentheses squared, but now we just have 2 different variables, so we're going to do it twice. And so instead of kind of getting confused on bouncing back and forth and putting in the b over 2 squared into one and then the other, we just start and kind of only focus on, let's say, the x's. So looking at my x's, ignoring everything else, I say my b is -6, my b over 2 is -3, so my b over 2 squared is 9, and that's what goes into my first blank. And I put it on the left side, so I have to put it on the right side. And then I reset. I say, okay, now I'm going to deal with my y. So my b is equal to 4, my b over 2 is equal to 2. I square my b over 2, I get 4, put them both into the blanks. Now, the completing the square step comes about when I do, I take my b over 2 for my x, and I put that in a parentheses next to it, so I get x minus 3 squared. I take my b over 2 of my y, put in parentheses next to it, so I get y plus 2 squared. And then if I simplify the right side of my equation, 4. And now I have my equation. I have it so that I can identify my center. I can identify my radius. My center is going to be 3, -2, 2, because the square root of 4 is 2. And then I would go through the exact same process that I saw in the previous slide of plotting my center, plotting points 2 above it, 2 below it, 2 to the right of it, 2 to the left of it. And since I just recently did it, I'm going to kind of spare you guys the details. That's going to be my end result. Looks a little bit weird because Desmos decided to kind of shrink down each box to actually be 1/2, so be aware of that. But it is correct. So I have 2, and then 2 boxes to the right of that would make it 3. And so then if I move up 4 blocks, I'm actually moving up a total of 2 to the right, 2 to the left, and 2 below. There might be a way to make Desmos not do that. I wouldn't be concerned if this showed up on a project and Desmos is doing something weird like that. I'd be able to fill in the blanks, but just watch for that. And that's true in general of charts, is make sure that if something looks a little bit off, maybe they're using a different scale than what you're used to. Or maybe you did something wrong, and then you can go back and check your answers. But that is an issue that happens, especially if you're using technology on that.